Okay, so in this question, we've got to determine the equation of the least squares line that can be used to predict the egg density in the forest from the number of male moths caught in a trap. I'm sure an exciting analogy of all this example. So we need to put all that data from that table into your calculator, which is just like this, preferably without that yellow band. And then once you put that data in, always double check your data. You got 9 data points, etc., etc. Otherwise, things can go wrong. And then you're pressing your calc button up here, and it's calc regression linear reg, and you should get that. And once you've got that, you can see we got our numbers. Now make sure you got this checked. I've got y plus bx. Okay. And the two numbers we want are the a and the b. Okay, now where a lot of people went wrong apparently on this one was that they couldn't round the numbers. Seriously. So it had to be to 1 decimal place, because it says it here, round the numbers to 1 decimal place, hidden under that part there. So we're just going to stick those numbers in. And so we get, now see, like this number's got the times by it, and that means we need the b dot the x dot is for the times. So it's the b that goes in this box, and it's 18.9, because we got 18.8963337. And just to show you how to do this, 1 decimal place, and we just look at this number. The 9 means you go up 1 to 18.9. This bit, that you don't even look at that. It doesn't exist. And they'll do the same thing for the next number. So we've got minus 46.84863, 1 decimal place, cut it off, look over. The 4, that doesn't matter. Doesn't matter if that's an 8 or a 6 or a 3 or a 1, right? Just a 4. 0 to 4, stay on the floor. Minus 46.8. And that's your answer. Okay, I think they're being a bit mean on these questions, but people really fell off the bandwagon, as it were, and got a lot of things wrong here because of this bottom corner. It doesn't cross at 0 again. That is such a common thing, and you really need to get into your head the habit of checking about that bottom corner, because if you do make a mistake, 3/4 of the people made that mistake. You catch this mistake, you are going to boost your mark way up. If you're getting the questions right that other people are getting wrong, that's when your ATAR is awesome. Okay, this is a bit embarrassing, because if you actually read what it says in the report from the VCAA, it was clear that some students did not take a ruler into the examination. So you're probably not going to get your mark if you don't bring a ruler. In fact, I'm going to emphasize that by ruling a line underneath it. There we go. Now, if we look at this equation down here, and noting that it doesn't start at 0, these are 2 important things to note, we can say, look, roughly, it's 200 times 30, sorry, not times, plus 30 times 10. And that's going to get you 500. So roughly, our first point for 10, x equals 10 is y equals 500. And this also means for about every 10, you're going up 300. So if we start here at 500, then 20 would be 800, and 30 would be 1,100, and 40 1,400, and 50 1,700, and 60 would be 2,000. Look, there's a nice numbers. So 2,000 and 60 is my other point. I'm going to put my ruler. Going to be good and actually use a real ruler. Just put it on the screen. Draw my line. That looks pretty good. I've got a few more dots above the line than below the line, but the ones below the line are actually a bit further away. So it kind of balances out, and it kind of looks right. If you'd done the sort of thing of doing 200 as your point, and then maybe, I don't know, calculating again some way the 62,000 point, you would get a line that looks like that. And you can see that that doesn't really, the green line's nowhere near as good as that red line in terms of determining how many points are above and below the line, or whether that's sort of balanced. Use your brain. Measuring by eye is actually quite accurate on these things. You should get a good sense of that. Okay, very common question. You should definitely hang out these ones. Interpret the slope of the regression line in terms of the variables. We've got two variables. We've got egg density and number of female moths. So these are very formulaic answers. You just need to get a formulaic sentence pattern. So your basic sort of sentence patterns could be, there are many variations on this theme. So for every increase in x of 1, y increases by m. Okay, so all you got to think about is what is x, what is y, what is m, and one more thing to consider: does it increase? First of all, let's answer that increase question. This is an increase in y, and this situation would be a decrease in y. What have we got from our previous question? We had the increase, so we don't have to change the increase. The x is the number of female moths, and the y is the egg density, and the m was the 31.3 from the last question. So all we've got to redo is fill out that sentence now. So for every increase in x, which is number of female moths, of 1. Now that's an important point. You had to say this one point has to be done. That's where a lot of people didn't get the sentence quite right. You have to mention that you're doing one of them, that the egg density increases by 31.3, because that was the gradient from the last question. All right, that was the other point to really make. They really wanted to emphasize that you had to say one of x for 31.3 of the y. If you don't say 1, it could have been like for every 10 it goes up by 31.3. And so they got a bit fussy about that, and so a lot of people didn't talk about that 1 or an additional 1, and they lost the mark. There's variations on this sentence pattern, but I would highly recommend getting out there and on your notes putting this and making sure you got these pictures so you as well, so you know whether it says an increase there or decrease, if anything is positive or negative. Okay, we need to know for residuals, so it says to determine the residual. So we need to know that formula, which is that the residual equals the actual minus predicted. Now, they have given us a prediction, sorry, the actual number, this one 1500. We got to find the predicted. So the predicted is basically putting the numbers into that equation. So if you remember, it was, if you do remember, so the equation was that if we take the egg density equals the 191 plus 31.3 times the number of female moths, So this is going to equal 191 plus 31.3 times 55. That equals 1912.5. So the residual is, residual equals 1500 minus 1912.5, and that equals minus 412.5. So you got to remember with your graph, when you've got a graph like this, you've got a dot here. That's the residual vertically up and down. And so that's more than the predicted, so it's positive. So these guys are going to be positive. Whereas if you have a dot that's below the line, which we do have in this case because 1500 is below the line of one which says 19125, then you get a line going down like this. That's down, and that's going to be negative. I know it sounds funny, positive is red and negative is green, but that's what it's saying. So any dot on this side is going to give a negative residual, and any dot on this side is going to give a positive residual. And if you're exactly on the line, 0. Okay, so another thing, make sure you've got that put in your notes, and don't be afraid of a negative number. A lot of people got that wrong because they probably wrote down 412.5 instead of negative 412.5 because it's below the line, or maybe just went bigger number minus smallest number and got them a bit confused. Make sure you got that formula. All right, classic question again, good one to spend some time studying. We've got the correlation coefficient R is 0.862, and so a lot of people went straight away and put that the percentage of the variation is 86.2. No, we want when you talk about the percentage of the variation, we need R squared. So this means we need R squared, yes, which is the coefficient of determination. My coefficient of determination. So we got to take the 0.862 and put it in a calculator. You can do 0.862, and then if you've got one of those class by calculators, just do hat symbol 2. That's don't never write that, but that's what you type on your calculator. So you're just using the front of your calculator and being quicker. Just get those little calculator tips. So you know that's exactly the same as what we actually write in math as 0.862 squared. And if you do all that and you type it into your calculator, you'll get actually that R squared equals 0.743. It says to 1 decimal place, and you go, cool, that's 0.7. No, it's not 0.7, because R squared always has to be as a percentage. So you've got to take that and times by 100, and that equals 74.3. So we can say the answer is 74.3%. Now, again, whenever you're studying, make sure you know the difference between R and R squared and how to change R into R squared, but also think maybe on this exam they'll do the reverse and give me R squared and tell me to find R. So you might be then thinking, do I know what R means? And you know R is all about that line where you have your 0 and then you've got your 1 and then you've got your -1, and that's for associations. So don't forget, again, let's divide that into our pieces. If you got all these notes in your book, so this is minus 0.25, minus 0.5, minus 0.75. This is 0.25, 0.5, 0.75. These are all things you should make sure you're understanding when you're looking at these questions. So we know, let's have a look at this area here. That is, let's do it in green, no correlation. And then if we choose a different highlight color, let's do blue this time, this area is, that is a weak correlation. What color should we go for now? Let's go for orange. This is moderate. So the orange is moderate. Correlation. I think you're getting the hang of that. And feeling a bit purple. Let's go for purple here. Very dark purple. Purple is strong. Correlation. Now, again, don't forget, you can then apply those words positive and negative and all that kind of thing. Do you know that? Do you have notes on that? The other thing to note is sometimes you have to do, this question was only a 1-mark question. So you only have to do one thing, put the percentage. Sometimes you have to do that whole sentence thing again. So similar to the question we were doing before, we have that whole sentence pattern. So if you had to do it as a 2-marker, they might actually ask you to say, all right, so 74.3% of the variation, now it's in the Y, can be explained by X. Sometimes people like to put these other things, so the rest can be explained by other factors. Not sure about that second part, but some people like to put that in there. So you just have to make sure you're changing your percentage to whatever your R squared is, and changing whatever your Y is and whatever your X is. So in this case, what was our Y? Our Y is the egg density, isn't it? So we'd have to write, sorry, let's try that again. That's egg density. That's the word you replace X with, and here Y with, and X is the number of female moths. Number of female moths, and that was just our R squared as a percentage. So make sure you get that. Sometimes you might have to be asked to write the full sentence, and that might be a 2-marker question. So can you see, whenever you're looking at a question, you don't just look at, okay, I've got the answer for this. Do I know what R is? Do I know how to make R squared? Do I know that R squared, I then square rooted equals R? And that's that sort of things. So look around a question. That's just strategy when you're studying. Make your notes, make your sentence patterns notes, so that you just have this generic fill-in